Hello and welcome to this online lecture about the advanced topic of conjugate acids and bases. So in the previous advanced lecture you learned about what are the Bronsted-Lowry concept of acids and bases. Along with that concept comes this idea of a conjugate acid or base. Basically the idea here is that after an acid-base reaction happens and one of the compounds gives its proton to the other compound, you're then left with two compounds that can do the reverse reaction, and it can give the proton back to its original owner. And so in that way you have kind of like an opposite reverse acid-base reaction that can happen. And when you think of it that way, you call the products of the first reaction conjugate acids and bases because they can be reactants for a second reaction. So let's take a look at this and see what the heck are we talking about here. So let's start with a pretty simple reaction, and we'll react a pretty strong acid with water. So we'll do hydrofluoric acid, which is HF, and we'll throw that in some water. Now I think by now you pretty much know what that does. It reacts with the water, gives off its proton, it creates a fluoride ion, and then it creates the hydronium ion, which is H3O+. So here we have, this would be considered an Arrhenius acid, plus it fits the definition of the Bronsted-Lowry acid because it's giving the hydrofluoric acid is giving its proton to the water. So that's literally what happens. It gives this proton right here to the water, and that's how we get the H3O, because one more proton with H2O is H3O+. And then of course that leaves the fluoride ion by itself. So we see that in the Bronsted-Lowry definition, a hydrogen fluoride is an acid, a Bronsted-Lowry acid, and water is the Bronsted-Lowry base. So what's this new idea of the conjugate acid and conjugate base? Well, the idea here is that when we first think about this reaction, we think about it proceeding in this direction as the arrow indicates. But often chemical reactions can actually go both ways. So let's actually think about it going the opposite way here for a second. So let me just let's change this arrow right here too, just so we don't get confused. So now we're going this way. Okay, so now for the reactants, we have the H3O+ and the fluoride ion. We have the hydronium and the fluoride, and they're going to react and they're going to make water and hydrogen fluoride. So let's think about what has to happen in order for that to occur. One of the hydrogens from the hydronium has to be given to the fluoride ion to create the hydrogen fluoride. So in that sense, if we think about the Bronsted-Lowry definition of an acid and a base, in that sense the hydronium is the acid and the fluoride is the base. So over here on this side we have the hydronium being an acid and we have the fluoride being a base. On the original side, the hydrogen fluoride was the, I don't like the way that I did that. Let me erase that base. I don't want to confuse you guys. In the original direction, let's write that again. There we go. In the original direction, it was the hydrogen fluoride that was the acid, and it was the water that was the base. But let's actually follow these through. Let's actually follow the actual molecules through. Like the water molecule right here is actually literally the hydronium molecule on this side. Now why is this important? Because look what's happening. Water, if you're going in the original direction, water starts out as a base and it becomes hydronium. And then if you push the reaction in the other direction, that hydronium acts like an acid, and it turns back into water. So we don't just call it just an acid, we call it the conjugate acid. It's the conjugate acid. So basically a conjugate is the acid or base that is formed from an acid or base in an original reaction. So we have H2O, and originally that's going to act like a base. But after the reaction occurs, it turns into H3O plus, which can act as an acid, so we call it the conjugate acid. And those two compounds are linked. It's basically the same compound, it's just gaining and losing a proton. And then the same thing would be true with the hydrogen fluoride. Originally we called the hydrogen fluoride an acid, and then after the reaction occurs in the original direction, what's all that's left after that is the fluoride ion, and we call that the conjugate base. Gonna miss that A up there. And so they form these pairs called a conjugate acid-base pair. The acid has a conjugate base, and the base has a conjugate acid. So what starts out as the acid turns into the conjugate base when it loses its proton, and what starts out as the base turns into a conjugate acid when it gains the proton from the acid. So that's the idea of conjugate acids and bases. And for your quiz, you need to be able to look at a reaction and try to identify the acid and the base, and then each one of their conjugates. So if you can identify the base, you should be able to identify the conjugate acid that it turns into. And if you can identify the acid, you should be able to identify the conjugate base that it turns into. That's it for this video lecture. Thanks for watching, and as always, if you have any questions, please feel free to ask in class.